Welcome all, Max of the Accidental Engineer. Today we have the pleasure of Alyssa Whitwell joining us.
Hi.
Alyssa is a data engineer at Clover Health here in San Francisco, California, USA. How long have you been with Clover?
I just hit my 2 years, actually.
Oh, nice. For our audience that has not heard of Clover or what it is that you guys do you mind sharing a little bit about what it is that you guys do?
Yeah, so Clover is a Medicare Advantage tech startup, and we're currently based here in San Francisco and in New Jersey. So all of our members right now are in New Jersey. We're actually a Medicare plan,
Okay.
so we contract through CMS and the government, and our business model is around using data and leveraging engineering and analytics and technology in general to improve their health outcomes. And it's really unique because if we improve their health outcomes, we actually are also financially profitable based on the regulations around CMS. So our goal is basically to have people lead healthier and more happy lives.
Makes sense. So for our audience that are curious about how you've made it to this point as a data engineer at a tech startup, do you mind sharing kind of what your background was from college through to today?
Yeah, so I graduated from UCLA in math and econ, and while I was in school, I did 2 internships at Hewitt Associates, which is now acquired by Aon. And it was basically a human resources consulting company. So we helped large employers figure out what kind of healthcare plans they wanted for their employees. And it was my first experience with healthcare, with consulting in general, and with working with actuaries. And it was right around the time when all of the PPACA, Obamacare legislation was coming up. I did it for 2 summers, so it was a really exciting time to be in that field. And then after college, I actually did management consulting. So I worked primarily with pharmaceutical and biotech clients, and I also focused on the mental health and oncology spaces. So I tracked basically market share for lots of different cancer drugs and pipelining. So for mental health drugs that were coming into market soon, presumably after they passed FDA trials. And it was really interesting work. It was really cool to see healthcare from a different perspective of the pharmaceutical company that is generating molecules. But it was also a little bit hard to take in terms of I was doing end stage cancer drugs, and I was tracking how long do patients with terminal lung cancer live so we can give them this drug. And after a while, I just kind of didn't want to be in that space anymore. It was very difficult to work when you're talking about people's lives.
That is completely understandable. Yeah.
So I was sort of looking for other opportunities, and I had kept in touch with a lot of actuaries I'd worked with and other mathematicians, and I ended up taking a position at Blue Shield of California, and I worked in their network and trend analytics department for 3.5 years. And I was in an actuarial department, but I was not an actuary. I was a data analyst, and I would basically use medical claims data to do financial modeling for hospital contracts. I would help calculate estimated cost ranges for people who had PPO plans and were looking for care. And that was extremely interesting, but I was really motivated to figure out how I could help people in the healthcare space more directly and use things like data and information about navigating the healthcare system to improve people's lives. So when I heard about Clover, the mission statement really resonated with me. We are really small. It was a really awesome opportunity, and I joined on the data science team initially. And then about 9 months ago, I started on the engineering team.
Awesome.
Yeah.
And one of the things I think a lot of our audience might suspect is that your undergrad doing math and econ is a pretty technical background, but from what we've talked about previously, learning to code has been a more recent development.
Yeah.
Being a management consultant, your first job out of college, didn't mean you were slinging Python or C code or anything like that. So, mind sharing for us how you got into software engineering as opposed to the analytics and analysis type of stuff that you were doing in healthcare?
So I took 2 courses in C++ in college. It was required for math majors, but it wasn't at the level of rigor to write like Python code. It was a good introduction. The hurdle of learning how to think like a machine or like think like a computer was there, and I think I kind of got it. I got to do some VBA work when I was in consulting and when I was at Blue Shield of California, but the exposure to a modern tech stack like at Clover was huge for me. So I had never worked with Postgres before. I never used a text editor before I came to Clover, so that was a huge change. And then when I started, we were so small. I got to interact with all of the engineers all the time. We were like all on the same floor. I would sit together with them. We got to do projects together, and I really started to pick up just on the ecosystem, I think. And Clover's primarily a Postgres and Python shop. So I had some exposure in terms of, like, we read a lot of unit tests, even on the analytics side. We have like SQL transforms, and we pair it with Python code because we want to make sure that the business logic is sound for what we're calculating. And so that was my first exposure to Python. And a lot of it, like, I started to pick up on it, but I didn't know that what was going on, or like, why would you write something a certain way? Like, why is this resource intensive? Why is this a bad practice? And I really got interested in it, and I was really interested in kind of the technical growth and mentorship opportunities that we have on our engineering team. So we started this new associate software engineer program in January of this year, and I actually joined from the data science team to be part of that first cohort.
Awesome.
Yeah, and we do like a dedicated mentorship with someone on your team, and so I had a fantastic mentor, and we did a lot of pair programming. And I remember, like, the first time that we paired together, I was so nervous because I was like, oh, I don't know anything. Like, she's gonna think I'm stupid. Like I don't know the first thing that I'm supposed to do. And she was super empathetic and compassionate about it. And from that point on, like, we paired together every day for like 3 weeks, and then I really started to learn, like, why you write code in a certain way. And basically from there, I've been striving to be more and more autonomous.
Mm-hmm.
Yeah.
So you mentioned before joining Clover as a data scientist and now as a data engineer, working with actuaries, which you may still do at Clover?
Yep, we have a team of, I think, 6 actuaries.
I think the profession of actuarialism is not well known among the general United States public.
Yeah.
Do you mind sharing for our audience what is an actuary and why you had to work with them in your jobs after college? Yeah,
so actuaries typically calculate risk. Like, that's the fundamental thing. You typically think of actuaries in the healthcare space, but they're also in, like, auto insurance, and I think property, I'm not sure, but retirement, pension, that's kind of going out of style now. But anywhere where you're trying to calculate the risk of someone doing something is there. So they have, like, tables where they calculate, like, your likelihood of dying, for instance, or your likelihood of getting into a car accident. So with respect to medical insurance, you're calculating, like, the likelihood that someone will have a catastrophic illness or, like, have certain types of claims, basically. And actuaries are really important for healthcare because you need them to calculate your insurance premium, because you need to estimate all of that information and plug it into your models, and forecasting. So if a large company wants to get health insurance, you have to figure out, well, how much should we charge per person per month? For sure. Yeah. So, I mean, it sounds like every role you've held since college has involved working with actuaries, and yet you've never chose to go down that path. Do you mind sharing why that is? Skills-wise, I'm sure there's a big difference between what you know now or what is valued in your role now versus what might be valued if you had chosen to go down the actuary path. Yeah, sure. So actuarial like tracks in terms of school require heavy math, heavy statistics. I did take a lot of math. I was a math major. I took some statistics, but what really defines the field is like these very structured tests that you have to take to get credentials. So you have to get 2 credentials, the ASA and the FSA, before you're fully credentialed as an actuary. And it's like 10 plus tests, and these tests are not like midterm tests or something. They're like you study 3 to 6 months for these things, and they're very expensive. Lots of study material. You actually often get time off if you're an actuarial student at an insurance company to study for these exams, and they will reimburse you when you pass them, and you get pay raises associated with it, and ultimately the companies will grow you to the point where you are credentialed, and then you can actually sign off on things. So if someone is calculating what the premium should be for an employer group for next year, if you have an FSA, you can sign off on it. You typically have like a chief actuary do the final sign-offs. But because of that, it's like a lot of structure, a lot of discipline, very, very rigorous. You typically have these very set things that you're trying to calculate, and then you have to be very confident that what you're doing is correct, because if you do something fraudulent, if you do something that's very negligent, like you can get your credentials taken away from you. So I like to think of it as you want this like very disciplined, structured path if you're going to be an actuary. And then when you look at something like data science or even data engineering, they're very brand new fields. People are still struggling to define what that means. And at every company, the definition for a data scientist or a data engineer is totally different. You have people coming from all sorts of fields. Like we have people who are PhD dropouts, people who did a bachelor's in math and then did some stuff after. You have people who have been engineers and they switch into data science, things like that. And there's much less structure throughout, and you're often sifting through large quantities of data or bad data, and you're trying to extract these insights. And it's really cool because you get to be iterative, you get to be innovative, but you can't really do that in an actuarial practice, right? You can't calculate premiums and then charge people premiums and then be like, actually, we're going to iterate on that and give you a different price. Like, that's just completely unheard of.
Yeah, and it's interesting parallel to engineering, where historically there's Hammurabi's code, where if a building collapses and kills somebody, whoever built the building gets put to death. And it's not a little extreme. People don't get put to death for signing off on actuarial forecasts that turn out to be incorrect, but I like that idea of professions where you have some skin in the game. Yeah. And actuaries have it, but to it, I feel, a fault. Yeah. Where it's so regimented that there's these tests, and there's not quite room for the type of creativity in design that there is in software engineering. Yeah. Where, like you were describing, tests and unit tests in support of guaranteeing that software works as behaved. Not so dissimilar from forecasts about healthcare insurance rates going awry or whatnot. So do you find that there's much in the way of parallels between what the engineering team at Clover focuses on versus what the actuaries at Clover focus on? I realize they have different responsibilities, but they both have risks, and there's different ways to hedge those risks, I guess.
Yeah, I think that actually the tension of having those two disciplines working together, and also data science being more toward like engineering, I think that that's really important. We have a unique challenge where we want to be innovative. In the healthcare space, it's full of legacy data, legacy code, legacy practices, inefficiencies. But at the same time, you can't just go and move fast and break things, right? Because breaking things means you're harming the member potentially, or you're not being disciplined in how you're looking at your impact. So I think having both is really key, because you want to be compliant at all times, but you want to be innovative, and we see that tension in all of our work. So I was talking to some of my coworkers and some of the actuaries, and they were like, well, we want to be actuaries, but we want to code more. We want to be more like engineers. And then there's something to be said about, we want to be, if we're engineers, like, we want to think about the member, and we want to be member focused, and what will this impact in terms of like member risk, member understanding of our plan. So I really think that it's a balancing act between both. Like, you need both characteristics.
Oh, for sure.
Yeah.
The vast majority of our audience does not have computer science degrees. They might have math degrees like you and me, and they might not have come to coding till maybe later in life, well past college graduation.
Yeah.
For those people who might be at the same point down the path of learning software engineering and coding, or maybe you yourself 3 years ago, do you mind sharing what the experience has been like, and how long it's taken to get to the level of confidence and ability that you now have?
Yeah. So my journey in engineering has been pretty brief. It's about 9 months so far. And one of the things that I struggled with the most was terminology and how to participate in a conversation. So as a member of the data science team, I would hear engineers throw around words like abstraction, wrapper, like those different kinds of things. And I was like, oh, I kind of know what an abstraction is, but I need like a tangible definition. So one of the best pieces of advice that I got from my coworkers was create like a spreadsheet or some sort of document and write down every single question that you have during the day and write the answer down, and then go back. And if like 2 weeks later you're still asking the same question, that's a problem. You need to figure out why. And that sheet ended up being like a definition sheet for me. So I found that as I was getting more of that information, I could suddenly contribute more to conversations, and I could actually understand the content of the discussion more. And being confident enough to stop my coworkers and be like, hey, I don't know what that word meant. Could you explain what that means and what it means in this context, was hugely critical. And I think that there's a point where you're kind of like, oh, I don't want to stop the conversation and ask, because everyone else probably knows what you're trying to say, but it's actually really important to say, like, could you clarify what you meant by that? Or I didn't understand your approach to that. Can we whiteboard it out? And suddenly you're really contributing to the conversation. You're maybe even having the other person clarify what they mean more. And when I was able to stop and ask those questions and change the direction of the conversation, the technical design discussion, whatever it was, I really felt like I was a part of the team.
Oh, for sure.
As I mentioned before, a lot of it is just actually writing code. So pairing sessions were hugely important to me. Being able to ask people for feedback on my pull requests, being able to contribute to pull requests, even if it was looking at senior engineers' code on my project and commenting like, hey, I don't understand this part. Is this doing what I think it's doing? Can you walk me through afterward? Was hugely important. So I think by the 5th or 6th month, I was really like feeling that I could contribute code, that I understood the conversation, and that I could ask questions in a way where I didn't feel insecure anymore.
Oh, for sure. This is what you're describing with taking notes of what questions you have that are unanswered or that you don't feel confident about asking in the moment, and keeping track of whether you are coming back to those questions is something that's not just true of people just starting out in software engineering, but it's true of people starting a new job just generally. I've found with software engineering teams, when people come onto teams, they always have questions about, why are you doing this way? I know of a better way for my last role. And what tends to happen is people drop their recommendations after a while because they don't have enough internal clout yet, or feel like they don't have enough internal clout yet in their new role to be able to advocate effectively for either making it a safe space to ask questions even, or initiate better ways of doing things, or clarifying code that might be obfuscated in some way. So I know exactly what you're talking about. One of the things that we've talked about before recording about getting started in coding is the specter of imposter syndrome.
Oh yeah.
So for our audience members who might not have heard it phrased exactly this way, do you mind defining imposter syndrome for people? And
I might have imposter syndrome about defining imposter syndrome.
Well, we can improv it.
Yeah, so I guess like imposter syndrome is kind of the feeling that like you're in this place but you don't maybe deserve the role, or maybe you're secretly not intelligent enough, or whatever, insert some adjective, enough to be there. So you kind of like, you really do a lot of self-downing, and you might be like, oh, I have a question, but is the question because that person wasn't clear, or was it because I actually have no idea what I'm doing? And then you kind of fall into this very terrible spiral where you just like lack confidence, and you're not actually able to improve because you're holding yourself back.
So for one, I think that was a great definition.
Okay, cool. That was
and
completely on the fly.
That jives with what I suspect it means too. How should people, or how can people self-medicate for this syndrome?
Yeah, I think having people who you trust, and being able to ask them for honest feedback. I think that having constructive criticism, even if it's reinforcing, is really important. So you were talking about like, people might not have enough clout in an organization. I was lucky where I had been at my company for a little over a year when I switched into the engineering role. So even though I was a brand new engineer, I had a lot of domain context. I had a lot of contributions to the company, not necessarily in terms of commits to like the pipeline repo or something like that, but I had delivered on a lot of things where I had relationships with people. So I could reach out to those people and be like, hey, like, am I being too hard on myself? Where can I really learn? My manager is fantastic, and she's been and she also switched into engineering. She switched from finance, and she's super empathetic and was able to give me a lot of advice and a lot of support when I was going into it. But I think like not being too hard on yourself. If you're coding and you're making mistakes, you're learning something. So as long as you're not making the same exact mistake like 5 weeks in a row, if you learn from it and you're on a new mistake, that's actually progress. And a good parallel is like debugging, right? Like when you first start coding and you hit some errors, you're like, I'm terrible. Why can't I get this to work? And then it's really understanding actually everyone hits bugs all the time. Even if you write awesome code, if you change it, like there's a bug. But if you are able to reason through it, change a couple things, hit a different error, like that's actually progress. And I actually saw that in how I approached debugging, like as I got better at it and was able to solve small problems iteratively until I hit the final solution. I think that's a good metaphor of like overcoming your imposter syndrome.
Totally. And to come back to the beginning of your answer, it sounds like finding peers or managers that are A, understanding, B, are empathetic, and have the spare time, or not even spare time, but the willingness to help out more junior employees. If you don't have that first engineering job yet, something that I found really helpful when I was trying to get into software engineering, my first job out of college was not software engineering, similar to yourself, was going to meetups. And when you might not be so experienced, you'll find that everyone else around you is more experienced, which is a great environment to learn from other people, because a lot of people have been in your shoes not so long ago, so they're the best people to talk to, as opposed to going out on the internet into the void and trying to find like-minded people over the internet. So getting out of the door and, and meeting people, whether it's at a new job or in person at live meetups, is another great way. I think.
Just as a quick plug, PyLadies is really awesome.
Absolutely.
For people who don't know, it's a very female-centered approach to coding, and it's for like beginners in Python. And there's chapters all over the country. Clover actually sponsors the San Francisco PyLadies, so every Thursday they use our space, and they usually have presentations. So if you want to practice giving a presentation, you can go do that. And they also have working sessions, and they have a mix of like experienced and junior people and like brand new people to Python, and it's a really supportive community. For
sure. I mean, seeing people like yourself who are coping with the same self-doubt is a really great way to deal with imposter syndrome, is recognizing that everyone feels similarly, and it's not totally justified to feel the way that you do. Is, I agree, a great way to self-medicate. I guess sharing for people who are a little apprehensive about picking up their first programming language. How did you end up picking up your first program? You mentioned your college classes in C++, but when you joined Clover as a data scientist, did you already have a toolkit of programming languages that you were familiar with, or did you adopt what was used by your new coworkers? Or
so my toolkit was really like SAS, which is sort of like a pseudo enterprisey version of SQL in some ways, and like debugging existing VBA code in Excel macros. So I didn't really have much of a toolkit, and my first task was like learning SQL, and it was just like, we use mode analytics at Clover, so it's basically a way to have like a web interface where you're querying the database directly, and then you can share your reports with other people. So I just wrote tons and tons of SQL queries, and eventually got the hang of it. And then if you contribute a SQL file to build a table in our repo, you have to do corresponding unit tests, which we write in Python. So my initial introduction to Python was like cargo culting things. And then gradually you learn more, and then the switch from just writing Python for unit tests to functional code that might ping our API layer, or eventually move data around different databases and stuff. It was gradual, but I was able to ramp up through that.
Got it. Were there any specific resources that, besides your coworkers, educating you up on this stuff, that you found helpful online, or events in person? You mentioned PyLadies, but were there any classes that you took extracurricularly? That kind of thing?
One of the big ones for me actually was How to Think Like a Computer Scientist, and I don't remember who wrote it, but it was recommended to me by a manager on the engineering team. And I had picked up a lot of things along the way from my career, which is about 7 years long at this point, right? And I had picked up bits and pieces, but I never got the foundational layer, and that was a huge gap for me. And again, it was terminology and basic understanding of how computers work, how compilers work, how interpreters work. And this course was great because it taught you all of those things at a basic level, and then taught you some Python along with it. And I think doing exercises in a REPL like IPython is really important because you get this immediate feedback loop. So I think the course has an embedded thing that you can use, but I was doing it, and I was just in the REPL side by side and trying to figure out how that worked. I also think existing repos are great. When you look at a code base, you have all of these examples of different ways of approaching things. So whether it's picking up examples, searching through the repo, and then sticking in a PDB set trace or something, so you can actually see the values that are coming out. I think those have been the most concrete ways that I've learned.
Got it. Are there any besides internal to your employer's
Yeah.
code bases, are there any public code bases that might be specific to Python that you looked at very early on and were very legible for a beginner to be able to read and understand the code and see in action what are some of the most basic of best practices?
Yeah, I think I've gone to the SciPy conference 2 years in a row. That's a scientific Python. It's a really great community, and they have tons of examples up that you can use, and you can kind of like sort through them. And I think even when you're taking these courses, if you sort of Google them, you'll actually find people who have done versions of the exercises, and you can sort of see what they've done.
Oh, for sure.
And that's super helpful.
We will include all this stuff in
Okay,
the post
great.
notes, links to SciPy, the conference, and how to think like a computer scientist. These are extremely helpful examples. Thank you for sharing them with us, Alyssa. I hope we get to do it again very soon.
Yeah, thank
Cool.
you.